All right, as we look at graph number 4, I've taken some things away from you. And the first thing I want you to notice is on the graph, I want you to notice these labels, okay? A lot of the time, our graph is just counting by ones. This is specifically telling us, in fact, that we are not counting by 1. We're counting by halves on the x and 3 on the y. So I've got a situation here, and we're going to sketch a rough graph through the zeros and the vertex. So I've given you this line. What does this line represent? This dotted line that I've got right here. This is our axis of symmetry. Okay? Remember, that cuts our graph in half. If I had to write an equation for this axis of symmetry, I need to first make sure I pay attention to my scale. So x equals what? If we're counting by every half, this is 1, this is 2. It's going to be 2.5 because it's between 2 and 3. If you wanted, you could go ahead and label the rest of your graph. Okay? Also, pay attention on the y. It's counting by 3s. 3, 6, 9, and so on. So really, if you label it first, that's going to keep you from having to stop what you're doing, and you can just go ahead and you can see your numbers, okay? Is there anything else we can tell from this graph before we start answering any questions? We said the axis of symmetry is x equals 2.5. Is there anything else we can tell? Maybe the vertex? What do we think?
Yes.
What's the vertex? 2.5 what? 30. Okay. Looking at our situation here, after scoring a touchdown, the kicker will attempt a field goal. The graph to the right represents the path of the ball. Use this to answer the questions. Okay, so if you don't play football, when they kick a field goal, that ball is on the ground when they kick it. There is a guy, he holds it. I don't remember what that's actually called, but they hike the ball to him, and that ball is physically on the ground when the kicker kicks it. So our kicker is starting at 0, 0. Okay, does that make sense? So if you didn't know, it's not like when they kick the ball off at the beginning and it's on the little T thing, right, where it's off the ground. It's physically on the ground, so we're starting at 0, 0. So if we know that the kicker is going to kick the ball, and here it goes, what do we know about that ball? It went up, it got all the way to 30 feet high, and then what? It came down. Where is that ball going to land on the ground? At what? At 5. I heard 5. Why 5 as opposed to 6? Yes, 2.5 feet away from that axis of symmetry. So that means because it is cutting it exactly in half, we need to be 2.5 feet away on the other side, which means that our ball is going to land 5 seconds later. Okay, so after 5 seconds, the ball landed on the ground. So we can answer all the rest of these questions. Based on the information, plot the point where the ball was kicked, okay? Well, we said the ball was kicked at 0, 0. What is that called? Okay, it is the origin, but it is also called a what? Okay, it's a y-intercept. It is the origin, but I'm looking specifically at, it is a rhox. It's a root. It's an x-intercept. It's a 0. It's a solution. And remember, we are starting on the ground. That's why it's at 0, 0. Okay? When did the ball hit the ground?
At 5.
At 5, 0. What do we call that? Define that. The ending point. It is also a rhox, right? It is also a root, a 0, an x-intercept, and a solution. They're on the x-axis. So when we talk about the path of the ball, your y variable always depends on our x variable because our y variable is dependent. So our y variable was height. So the height of the ball depends on the seconds from being kicked. Okay? Use our quadratic equation with the points. Find the quadratic equation using the points. We're going to use our calculator for this. We did this the other day. To do that, let's make a little table over here of the coordinates we have so that we can know what we're putting in the calculator. We have 0, 0. We have 2.5 and 30. And we have 5, 0. So in order to write a quadratic equation, we need to have a minimum of 3 points, which we do have. So you can go to List in Spreadsheets and do menu 416. We talked about that the other day. Or you can go to Desmos, put in your table, and you can do y1 squiggle ax1 squared plus bx1 plus c. So you have a couple of different methods to do this. So we need to write our equation. Y equals negative 4.8 x squared plus 24x. Where is the ball after 4.5 seconds? So this is where Desmos is going to come in handy, or you can use your calculator. 4.5 seconds. Seconds was our x. So you can do a couple of things. You can say negative 4.8 times 4.5 quantity squared plus 24 times 4.5. Or you can go to Desmos, you can type in x equals 4.5 and you can find where they intersect. Either way will work. So you can type that in and solve it, or you can look for the intersection. Either way, it tells you you are 10.8 feet high. That's how high the ball is at 4.5 seconds. Using your calculator, determine the interval when the ball was more than 20 feet high. Okay, so this is our y. Height is our y. Add the graph of a horizontal line. So let's look at where that goes. So at 1.05, that was seconds, and 3.94 seconds. It does ask us to write it as an interval, right? These are going to be our ending points. So we could technically write this, because we're talking about x, we can write it almost as a domain and say that in between those times, that's when it was at or above 20. So why does it appear twice? What goes up must come down. Our domain, because we do have a starting and a stopping, we were at 0, less than or equal to x, less than or equal to 5 on our seconds. And our range was our height, so 0 is less than or equal to y is less than or equal to 30. Where is the ball going to be at 6.5 seconds? On the ground. Why? Yeah, it's on the ground because it landed at 5 seconds. So from this, I want you to be able to take, depending on what they give you, you should be able to solve the puzzle and find the other pieces so that you could find all of the things necessary. So we've typed in our y equals 20. We tapped where we had our intersection, and we can see it at 1.05 seconds and 3.94 seconds. That is when the ball is at 20 feet high. Why are there two? Why are there two of these points? Yeah, what goes up must come down. So at two different times, on the way up, it was at 20 feet high. And on the way down, it was also at 20 feet high. So 1.05 and 3.94. So using Desmos of the yellow calculator, you should have gotten Y equals negative 4.8x squared plus 24x. You could put plus 0 for the c because that was the y-intercept, but you don't have to put that. So whether you did this in Desmos or you did it in the yellow calculator, go ahead and retype that equation. So if we need to find anything else, we've already got it there. You can see the little dots. You've got your roots and your vertex.